How can you assess the impact of a change in a set of requirements? Let's take the example of a car headlight controller with an automatic mode that switches the headlights on when it's dark and turns them off when it's light. Here is the first version of the requirements. You can test this set of requirements using the block diagram in Stimulus, and we observe the expected behaviour. Let's look at these requirements more closely. These two correspond to the hysteresis zone, above 60% and below 70%. When headlight was on, it stays on. When headlight was off, it stays off. You may want to be more precise with the condition and write when light intensity is in the 60% to 70% range. Let's make these changes in a copy of requirements _ version 1. We use the in-range operator and some copy-paste actions to update the requirement. We now have a second version of the specification. How can you check that no undesired behaviour has been introduced? With Stimulus, you can compare the two versions. Let's go into the test environment and put version 1 in the block to be tested and create an observer for version 2. We create a paragraph, we drag and drop version 2, and we choose the mode Observer. Let's run a test. We make 200 steps. The observer is green, so the behaviour of version 1 is a subset of what is allowed by version 2. Let's make 1000 steps. Same result. In order to check that the two versions are equivalent, the opposite verification must still be made. We drag and drop version 2 into the block to be tested and version 1 into the observer. The same test is repeated. The observer turns red. Version 2 violates the requirements defined in version 1. When does the error occur? Let's add the observer to the plotter view, and we clearly see the moments when the two versions diverge. Let's zoom in. At this point, headlight is no longer constrained. It switches from on to off freely, whereas it was not the case in version 1. With Stimulus, you can detect the error and correct it immediately.